Welcome back to my YouTube channel. In the course of this video lesson, I'll be solving all practice questions that cut across the topic stoichiometry from the scratch. So make sure you watch this video till the end because it will help you improve greatly in this aspect of chemistry. So let's get into the first practice question, and it says, calculate the number of moles present in 2.5 grams of CaCO3. Now, this question is extremely very easy. But before we start solving this question, I have to quickly do a quick recap. I already have a full video lesson on this topic, stoichiometry, where I explain every single concept that must be noted under this topic. Okay, the link to watch that video will be in the description of this particular video, but make sure you watch this video till the end because I'll be solving all practice questions that pertain every single concept under this particular topic, stoichiometry. Now, there is something that must be noted whenever we talk about stoichiometry. It is extremely very important. And what is that? N. The symbol N. It simply means number of moles. And this number of moles is given by 5 important formulas. Are you getting me now? In that video lesson, I explained everything from the scratch down to conversion factors and everything you must know under this particular topic. But still, in this video lesson, with all the practice questions I'll be solving, I'll make sure that it cut across every single aspect. So make sure you watch this video till the end. And if you are just joining this community and you haven't yet subscribed to my channel, make sure you subscribe to my channel so you don't miss out whenever I upload a new video lesson. So let's get into this aspect. I have said that N simply means number of moles, and it is given by 5 formulas. Here are the formulas. The first one is number of moles is equal to mass divided by molar mass. All of these things are parameter. Mass is a parameter, molar mass is a parameter. I'm going to talk about them as to solve different practice questions. Where for the other formula, number of moles is equal to concentration times volume in dm cube divided by 1. Concentration, volume, they are all parameters as well, whereby the third formula is number of moles is equal to PV dividing RT. I'm going to tell you what each of them mean as we progress solving practice questions. And the first one is number of moles is equal to volume at STP. STP means standard temperature and pressure dividing 22.4 dm cube. Are you getting me now? The volume here is in dm cube. I'm going to elaborate as I solve practice question on each of the concept, and as I solve, I'll give your own, so you solve and provide the answer in the comment section. Whereby for the last formula, the fifth formula is number of moles is equal to number of atoms dividing this number, which is 6.02 times 10 raised by 23, and it is called Avogadro's constant. So on this, how do we solve this first practice question? It is extremely easy, but before I solve, I have to tell you something very important that will help us solve questions under this particular topic. Okay, so whenever we see a particular how am I going to say it now? Whenever we see a particular unit assigned to a number, we have to know what parameter that unit is all about. Now, this is what I mean. Whenever we see grams, when solving questions under this aspect, just bear that in mind that that is your mass. Are you following me? It is very, very important. In chemistry, mass is most times in grams. But in physics, mass is most times in kilograms. Are you getting me now? So sometimes in chemistry, they might give you mass in kilograms. So don't solve that way. Make sure you convert it to gram. I'm going to give you a practice question on that particular aspect too. Do you understand? So whenever we see this unit as well, we simply know that it is molar mass and it is grams slash moles. This slash means per. So it's pronounced grams per moles. Are you following me now? I don't spell the mole. That's how it's written. Grams per moles. Now, moving further, whenever we see this unit assigned to a number, let's know that it is concentration. And what is that unit? It is simply moles per dm cube. Are you following me? It is very, very important. And also, whenever we see units like dm cube, as seen here, or cm cube, or liters or milliliters or meter cube. All of these are units for volume. So we know that those numbers are what? Volume. We will solve practice questions as we progress in this video lesson. So make sure you stick to the end of this video because it will help you. So for this is pressure, this is volume, this is okay, I'm going to talk about them when we get to the concepts. Do you understand me? It is easy. Just hold on. Meanwhile, for volume is still the same as volume, so we've talked about that. And for number of atoms, you see that they'll write the number and they'll write the number of atoms at the end. They'll write the number and they'll put atoms at the end. So you know that that number is your number of atoms. As we progress, we're going to solve questions on each of the formulas. So guys, the first question we'll be solving is on the first formula written here, so it will not be hard for us to assimilate. So the question says, calculate the number of moles. Wow, they're asking me to calculate number of moles. I already know that number of moles is symbolized as N. So I'll put that in my mind. So present in 2.5 grams of what? CaCO3. Wow, 2.5 grams. What is this value? Is this value mass? Is it molar mass? Is it concentration? Is it volume? What's 2.5 grams? 2.5 grams is mass. So then on 2.5 I'll write mass. So I'll put that in my mind. And they gave me a compound. We have to know that with our compound, we can get what we call molar mass. Are you following me? So I believe you already know the formula to apply, because the first set of questions I'll be solving in this particular video lesson explains me solving questions using each of the formulas. Because we have other cases where we have to combine formulas together. It is extremely easy. Make sure you watch and follow all the steps I'll be taking to solve questions. Because at the end of solving this, I'm going to give you another one so you solve and provide the answer in the comment section. So moving further, calculate number of moles present in 2.5 grams of CaCO3. That's the compound. It is popularly regarded to be called limestone, which is iopacly calcium triosocarbonate 4. The way I got that is extremely easy as well. Are you following me? I'm going to explain this in subsequent videos because it's not on the topic stoichiometry. It's on another topic. Are you following me now? So moving further, which formula are we to use to solve this question? It is simply number of moles, because there is mass, there is molar mass. Yes, because we have to use the compound to get our molar mass, which is number of moles is equal to, okay, mass divided by molar mass. Very easy. Now, what was the mass? Because they asked us to get number of moles. What was the mass given in the question? The mass given in the question is 2.5 grams dividing molar mass. Now, the compound they gave to us is CaCO3. And remember, for you to calculate your molar mass, you have to know atomic masses of each of the elements involved forming that compound. So in your examination question, you'll be given, are you following me now? But it's best you still know it inside your cerebrum. So on this, how do you calculate our molar mass? Very easy. Molar mass will be calculated by adding the atomic mass of all the elements. Calcium atomic mass is 40. It's something you should know. At the end of finishing calcium, I'm going to add. I'm going to plus carbon atomic mass is 12. It's something you should know as well. Plus, you can say I'm done with carbon. You plus, when you're done with the particular element, you add. Plus, oxygen atomic mass is 16. But now, I believe you can see a number standing in front of oxygen. In that video lesson on Stoichiometry, I explain every single concept. I'm still going to do it here. Whenever you see a number standing in front of a particular element, you times it. Do you understand? Because these guys don't have any number, that's why we just add them. Just call the atomic mass. So 16 times 3. Are you following me now? So what becomes the molar mass when we add everything in the calculator? We're going to get 100 grams per mole. Are you following me? 100 grams per mole is the molar mass of CaCO3. And remember, gram per mole is the unit for what? Molar mass. So underneath here, I'm going to write 100 grams what? Per mole. So what do we do next? We have to cancel. Gram cancels grams. So what becomes number of moles when we solve at the end? So it's going to be 2.5 dividing 100. That's 0.025. Wow. So we are having 0.025. What is remaining? Moles. Are you following me? So the answer to this question is 0.025 moles. Well, I'm going to give you one practice question, so you solve and provide the answer in the comment section. Okay guys, here is your own practice question, so you solve and provide the answer in the comment section. So we'll progress to the next practice question, which is question number 2. Okay guys, moving further, let's get into the second practice question. Now, what is the question? It says, calculate the mass Wow, they are still asking us to get mass. Present in 2.3 moles. Wow, 2.3 moles is what? And that is the number of moles. They already gave us the number of moles of the particular substance. And the substance here is just what? Sodium. So what do you do to solve this question? Extremely easy. They are asking me to get mass. They gave me N, which is number of moles. Then which of the formula do you think I should apply? And they gave me the element, which is sodium. And with them giving me the element, I can actually get the molar mass of the element. They already given us the molar mass of the element. So which of the formula you think I'm to apply to solve this question? It is extremely easy. I'm still going to work with the first formula, which is number of moles is equal to mass divided by molar mass. And what's the formula? It is number of moles is equal to what? Mass divided by what? Molar mass. So what do we do next? What are we to make subject? They say calculate mass. So we have to make mass subject of formula. To do that, you have to cross multiply. Do you understand? Cross multiply, what are you having for mass? Mass will not be equal to what? When you cross multiply, you're looking for these two with times. Do you understand? N times molar mass dividing 1. Simple. It's going to be N times molar mass. Do you understand? And what was the N value given in the question? The N value given was what? 2.3. So here become 2.3 mole. Okay. Times what was the molar mass given? 23. Remember that's the molar mass. So adding the unit to it is going to be 23 what? Grams per what? Moles. Remember what are we to look for? Mass. So you simply times 2.3 times 23, that is 52.9. Okay, so the mass becomes what? 52.9. Remember, what's the unit of mass in chemistry? Grams. But definitely you already know that we have to get grams if we cancel out the moles. When moles cancel each other, we have to get what? Grams remaining. So the answer to this question is 52.9 grams, approximately 53 grams. Do you understand? It's extremely very easy. So I'm going to give you one practice question so you solve and provide the answer in the comment section, whether I will change this 2.3 now to, let's say, 3.9 grams, 3.9 moles of another element. The element I'm going to make here is potassium, okay, instead of sodium. Potassium. Okay, and make sure you solve and provide the answer in the comment section. Potassium is symbolized as K, and the atomic mass is 39. Do you understand? So what becomes the molar mass here? 39 grams per moles. Are you getting me now? It's extremely very easy. So let's get into the third practice question. Okay guys, moving further, let's get into the next practice question, and it says calculate the number of moles. Wow, they're still asking us to calculate number of moles. We already know the number of moles is symbolized as N. Don't forget this. Of iron 3 oxide. Wow, I'm going to work on that. Simple. Present in 1 kg of the compound. So then, me seeing kg, I already know, I said this initially, I already know that kg, grams, kg or just g is mass. Do you understand? But we have to be careful. This is chemistry. Okay? And now they are asking to get number of moles. They gave me mass. They called out the compound. So with the compound, we can get what? Molar mass. Are you following me? It is extremely easy. So what do we do next? What do we do next? Simple like A, B, C, D. So now we have to see, they are asking us to get number of moles. We are giving mass and also molar mass. So which of the formula are we to use? Same formula, which is formula 1. The first formula, which is number of moles, is equal to what? Mass divided by what? Molar mass. So moving further, when we giving mass, yes, 1 gram. But what did I say? In chemistry, always make sure that your mass is expressed in grams, not in any other unit. It must be expressed in grams. So what do we do next? We have to simply know this simple conversion. We have to know that in chemistry or science generally, 1 kilogram is the same thing as 1,000 grams. Are you following me? 1 kilogram is the same as what? 1,000 grams. So automatically, the mass which was given to 1 gram before in the question will change to what? 1,000 grams. I said that in chemistry we don't solve with kilograms. We always solve with what? Grams. So moving further, what do we do next? How do we get the molar mass? Were we given the chemical formula of the compound? No, we were not. So first, before we get the molar mass of the compound, we have to get the chemical formula together. And to do that is extremely easy. The compound they gave to us is what? Iron 3 oxide. See, it is very easy like A, B, C, D. Let's form the compound together. See, it is between iron, say they said iron 3 oxide, that means it is between iron as an element which is symbolized as F3, but what type of iron? Iron can be of two types. We have iron 2 and iron 3. This one given to us is iron 3. Are you following me? See, they wrote 3 here, so it's iron 3. Why is it plus? Because iron is a metal. Metals are positively charged. Oxide. Oxide means oxygen. And oxygen oxidation state mostly occur as -2. Or can as well just say 2 minus. Are you following me? Listen carefully. Oxygen oxidation state mostly occur as what? -2, which you are seeing here. So what do we do next? How do we form the compound, which is iron 3 oxide? Then we change. We then exchange the charges. For 2 that is here without the minus, will move over to iron. So it's going to be Fe2. The 3 in iron will move over to oxygen. That's how you exchange it. O3. Are you following me? Without the sign, be it plus or minus. So you can see that we've gotten the chemical formula of iron 3 oxide together. So let us calculate the molar mass of it. Iron 3 oxide, Fe2O3. So what becomes the molar mass, everybody? Okay. Is going to be equal to, what's the atomic mass of iron given the practice question? It was given to be 56. So it's going to be 56, and we know we have 2. You know what to do, times 56 times 2 plus oxygen atomic mass given already to be 16. And how many of oxygen do we have? 3. So it's going to be times 3. So what becomes the molar mass? Molar mass will now be equal to, I think, 160. Okay, 56 times 2 plus 16 times 3, that is 160 grams per mole. So here it's going to be 160 grams, G/moles. Are you following me? Very easy. So then, under molar mass, we write 160 grams per what? Moles. So what happens next? Gram cancel gram, remaining just moles. Are you following me? So what becomes number of moles, everybody? So it's going to be 1000 divided by 160. That's 6.25. Okay, so number of moles now be equal to 6.25. What is remaining? Moles. You following? That's how it's done. It is extremely very easy. So 6.25 moles is the answer to this particular practice question. So I'm going to give you your own practice question, so you solve and provide the answer in the comment section. And here will be iron 2. I will just change it to iron 2. That's what I'll do. I'll change it to iron 2. So I believe you know what to do. Please be very careful. Okay, you already know that the iron here will not be 2. Do you understand? The iron here will not be what? 2. Let me just, the iron here will be 2, and then oxygen here will be 2 as well. It does not change. When you exchange both of them and you see that both of the numbers are the same, what do you do next? You can't just leave it like that. You have to bring it down to the simplest thing. You have to bring it down to the empirical formula. I'm just giving you a hint on what to do. Bring those, you've gotten the 2 numbers. So split it, break it again. Since 2 is for oxygen, 2 is for iron, 2 can cancel each other now. I believe you know where I'm driving towards. And then after getting molar mass correctly, I come and provide the answer in the comment section. It's extremely very easy. Okay, so let's get into the next practice question. So let's get into the 4th practice question, and it says 1 moles of a compound. This is the compound NHCO3. The compound is not complete. Just listen. Has 84 grams. So they told us that this compound has what? 84 grams. It is 84 grams. That's the mass of the compound. Now the question now says, calculate the atomic mass of N. You know that elements, different elements in chemistry have their specific atomic mass. So that's what they're asking us to determine now by calculation, because it was unknown. M standing here now is not an element that is known. So they are asking us to calculate the atomic mass so we can actually predict what element can be here, because M is not an element at all. So what do we do? Simple. From the parameters given to us, solution. So moving further, I saw first 1 moles. That means number of moles is 1. Are you following me? N is 1. Of this compound NHCO3, okay, has what? 84 grams. Remember, anything grams is mass, so 84 grams is what? Mass. So what do we do next? What do we do next? Simple. And the compound was given to be what now? NHCO3. Wow. So everybody listen carefully. So solve question under this aspect. First, so since the compound is not completely known, can we determine molar mass No, we cannot, because you already know that to calculate your molar mass, you simply add the atomic masses. And if you check what they give to us, they give us the atomic mass of M. No, we're not giving the atomic mass of M. So what do we do to solve this question? First of all, let us listen carefully. We have to still use the first formula, which is number of moles is equal to mass divided by what? Molar mass. So then let us make molar mass subject of formula. Let's try to determine molar mass, because we're giving number of moles N and we're giving mass. So to determine molar mass, what do? We want to make this subject with times. We are making this subject, this and this with time before you divide by what is up here. Simple. So molar mass will not be what? Listen carefully. Molar mass will not be what? Mass, okay, times 1 divided by what? N. That's your molar mass. Okay, guys, moving further, what becomes molar mass? Simple like A, B, C, D. Molar mass now, because what's the mass? The mass is 84. Wow, 84 grams times 1 is 84 grams. Divided by, what's the number of moles given according to the question? 1 moles. So here, divided by what? 1 moles. So what do you think we do next? Simple. So 84 divided by 1, what becomes that? It's going to be just 84, right? So it's going to be 84. But bringing the unit together, there is gram up, there is mole down. So it's going to be grams, and there is slash here, there is divide. It's going to be grams divided by what? Moles. And you already know that gram per mole as a unit is what? Molar mass. So we've gotten the molar mass of the compound to be 84 grams per mole. Wow. So here is the compound. Though we don't know what M is, but from the parameters given to us, we've calculated the molar mass, that the molar mass is 84. We've predicted that the molar mass is 84 grams per mole. But with this alone, can we determine M? Yes, we can, because we're giving values for the other elements' atomic masses. So what do we do to get our M? Now, simple like ABCD. Remember, if you want to calculate your molar mass, you simply add the atomic masses of the elements. So first of all, let's calculate molar mass together. Though we've calculated it from the numbers given to us, the values. So let's assume we want to calculate molar mass. So M will now be, after finishing with a particular element, you proceed to the other element by adding. Plus, what's the atomic mass of hydrogen? 1. Are you following me? Plus, what's the atomic mass of carbon? 12. Are you following me? Plus, what's the atomic mass of oxygen? 16. But how many oxygen do we have? We have 3. So it's going to be 16 times 3. Are you following me? Is equal to what we had from the other calculation, 84 grams per mole. So let's solve together. Let's add. So here will be M plus, so 1 plus 12 plus 16 times 3, what's that? 1 plus 12 plus 16 times 3, that's 61. Wow. So 1 plus 61 is equal to 84 grams what? Per mole. Do you understand? So what we do next? We simply make M subject of formula. Do you understand? So making M subject of formula, this 61 that is plus 61 will cross over to this side to become what? Minus 61. Because when you cross equality, you change, your sign will change. So it's going to be 84 minus 61. Do you understand? So what become M? 84 minus 61, that is 23. Wow, M is 23. And an element that has the atomic mass to be 23 is most likely to be sodium. Are you following me? It is very, very important. So this thing where we are having M is supposed to be like NaHCO3. It is called sodium bicarbonate. Do you understand? Or you can also say sodium hydrogen carbonate or sodium hydrogen trioxocarbonate 4. Me pronouncing all of these names, there are reasons to which I'm doing that, and it will be explained in other video lessons. Do you understand? It is not on the topic stoichiometry. So you can see how questions under this aspect are being solved without stress. And actually, you can see that they are still on just one formula, solving diverse ways question can be asked. Do you understand? It is extremely very easy. If you find my video lessons helpful, make sure you click on the subscribe button so you don't miss out my other video lessons to be uploaded. Okay guys, let's get into the next practice question, and it says calculate the number of moles. They are still asking us to get number of moles of H2SO4 solution. H2SO4 is a compound present in, these are very important here, present in 200 cm cube of 0.2 moles per dm cube. So what do we do to solve this question? They are asking us to get number of moles, which is N, and we already know the formula is written on the board, but we have to be careful on which of them specifically are we to use to solve this question. It's extremely easy. It's not all the time we use this formula, because now this question requires us to use another formula. So we have to determine the formula together. Remember I told you that whenever you see cm cube, dm cube, liters, milliliters, meter cube, you already know that that is volume. So this 200 cm cube is what? Volume. But now the volume was expressed in 1 unit cm cube. We have to be careful. And anything that ends with mole per dm cube should be what? Moles per dm cube should be what? Concentration. Wow. So which formula should I use? Is it the first, second, third, fourth, or fifth? It is the second, which is concentration, okay, times volume. We have to be careful. Divided by, hold on, you know, divided by 1. That's how the formula was written on the board. But now there will be alteration of this formula because of the way the question was asked. Listen carefully. Now, if you observe, you can see that the volume I wrote here, I said that you always divide by 1 if your volume is in dm cube. But now in this practice question, the volume was not in dm cube, but rather in cm cube. Please, whenever your volume is in cm cube, you make sure you divide by 1000. Are you following me? It is very, very important. But let's say the volume given to us here was in dm cube like that, we divide by 1, or you divide by nothing. No, dividing by 1 is like saying divided by nothing. Do you understand what I'm saying? So what do we do next? What do we do next? We just impute parameter, what become number of moles. What's the concentration given to us? It is 0.2. So here becomes 0.2. Okay, you don't have to stress yourself. 0.2 moles per dm cube times, you know, volume is what? The volume is 200 cm cube, 200 centimeter cube, dividing 1000. Hope you know, I've explained that already. So what becomes number of moles is going to be 0.2 times 200. That's 40. 40 divided by 1000. That is 0.04 moles. Are you following me? So this is the answer to the question. Is extremely very easy. Make sure whenever you see numbers like these, values like this, make sure you know the formula specifically to be used to solve that particular practice question, because they are all extremely easy. So make sure you get ready for your own practice question, and your question is going to be this: calculate the number of moles of, let's just change it now, if you observe of any OH. Okay, now if you observe something, did we actually use the compound now to calculate molar mass? No, it's not all the time you calculate molar mass. We'll just give you the compound there to just confuse you. Maybe you think you always calculate molar mass. No, it's not all the time. In this particular question, you have to look at the numbers given to you, the unit, so you know that, okay, they are asking me to use this second formula. Hope you understand. So here is yours. Here will be 500 centimeter cube, 500, and here will still be like that. So make sure you solve the question and provide the answer in the comment section. It is extremely very easy. Okay, so let's get into the next practice question. Moving further, let's get into the next practice question, and it says calculate the number of moles. I already know that we are looking for N. Okay, put that in your mind. Present in 250 cm cube. This is volume. Put this in your mind. Of an LD gas. I'm going to just tell you a trick. Most times, whenever you are solving questions on number of moles and you simply hear LD gas, your mind have to go back to an equation called the LD gas equation. And that equation is simply this: PV is equal to nRT. This is the LD gas equation. It is from this equation we actually got the formula, which is number of moles is equal to PV over RT. Let us make number of moles subject to formula. To do that, we divide both sides by the coefficient of number of moles, which is N. What is the coefficient of number of moles? R and T. So we divide both sides by R and T. What is close to number of moles? R and T. So what happens? R and T cancels R and T. So what are we having? So number of moles will now become what? A PV over RT. So whenever we hear LD gas in a particular practice question, just know that this formula should be used. Do you understand what I'm saying? Exerting a pressure. Let's analyze the parameters. Exerting a pressure of 700 mmHg. Listen carefully, this particular aspect is very important. At 27 degrees Celsius, and that is temperature. Listen carefully. That is what temperature, which is 27 degrees Celsius. So what are the other parameters? They gave me volume there, which is V, and it is 250 cm cube. And also, what did they give us again? Okay, they asked us to get N, which is number of moles. What do we do to solve this particular practice question? It is extremely very easy. And now, observe something carefully. Have I even talked about arrow? I've not even talked about arrow. I've not even explained to you what arrow means. Do you understand? So what does arrow mean? Arrow simply is a constant called the molar gas constant. Or if you don't call it that, you can as well call it the LD gas constant. Anything that's a constant is going to be a number. Do you understand? But for this level of the Jamb exam, post-UTME examination, the arrow constant, they are of two. Note it. They are of two kinds. The first one is 0.0821 and the other is 8.314. Do you understand? There are cases to which we use each of them. But I'll be explaining for just this. I don't stress you too much. Because if you understand one, you can actually solve and get the correct answer. It is said that, like, if you understand both, applying both carefully, you will arrive at the same answer. Do you understand what I'm saying? If you know both and you apply both carefully, you'll be able to solve a particular one question and get the same answer by using different constants. There are cases, there are criteria to which we use each of them. I'll be explaining for just this. In my video on stoichiometry, I explained the two criteria. Do you understand? So it's not because I'm solving this question, I'm using this constant. I can actually use this constant and get the same answer. Do you understand? So note this. We use this constant whenever our pressure P is in ATM. What's ATM? Atmosphere. We also use this constant whenever our volume is in dm cube or liters. Note what I just said. We use this constant whenever our pressure is in ATM and whenever our volume is in this dm cube or liter. Now check. The pressure in the question, was it in ATM? No. Pressure was in mmHg. You remember I said that I'm going to tell you various units to which pressure can be. Pressure can be in mmHg, which is millimeters of mercury. Pressure can be in ATM. Pressure can be in bar. Pressure can be in Pascal, as the case may be. And lastly, pressure can be in Newton per meter squared. Pressure can be in cmHg, as the case may be. Yes. So now, I just said that for we to use this constant, our pressure must be converted to ATM, which I will teach you how to do that. How to convert any pressure to ATM. But in this case, we are converting mmHg to ATM. And also, our volume must be in dm cube or liters. Okay, whereby the volume given in the question was it in dm cube? No, it was in cm cube. So we convert it to what now? Dm cube or liters. Converting this value to dm cube is automatically saying that we've converted the value to liters, because dm cube and liters, they are the same thing. Do you understand? So what do? Let's go on and solve this question together. Okay, this is the formula to apply, and I'm giving the criteria on what to use to solve this question. And lastly, you must note that your temperature in degrees Celsius must be converted to Kelvin, and I'm going to explain all of these things for you. And at the end of solving this practice question, I'm going to give you also a solve and provide the answer in the comment section. Okay guys, let's work towards the pressure first, to convert pressure to ATM. So you have to note this conversion factor. You have to know that 700 mmHg, 700 millimeters of mercury, is equal to 1 ATM, called atmosphere. ATM means atmosphere. Do you understand? So my point here is this. With this conversion factor, we can actually convert 700 mmHg to ATM. So automatically, the 700 they give to us will come down. So it's going to be 700 mmHg is equal to X ATM, what we are converting to. It's simple. In that video lesson, I explained conversion factors for all the parameters. So go watch my video lesson on stoichiometry. Meanwhile, let's progress. So what become X ATM? X ATM now be equal to, you are multiplying this to time, 700, okay, mmHg times 1 divided by 760. Hope you understand what I just explained, those simple like ABCD. So 700 times 1 divided by 760, that's 0.9211. So this 700 mmHg is automatically same as 0.9211 ATM, but it is this we are using to solve the question, not this 700. Do you understand what I'm saying? It's very, very important. So the next thing we do is to convert now volume from cm cube to dm cube. This is very easy. Okay, you have to just know that 1000 centimeter cube is equal to 1 dm cube, or we can access it equal to 1 liter. Simple. So what was the value given to us? You bring it down underneath it, make sure they're in the same part. 250 cm cube will now be equal to what? X dm cube, right? So what becomes x dm cube? X dm cube will now be equal to what now? 250, hope I'm not fast, 250 times 1 dividing 1000. What becomes x? Okay, it's going to be 250 times 1 dividing 1000. That's 0.25. So I'm having 0.25 dm cube. Do you understand? So here going to be equal to what now? 0.25 or dm cube. Whereby lastly, let us convert the temperature to Kelvin. Do you understand? Simple like ABC. To convert temperature to Kelvin, you have to know that Kelvin temperature is equal to degrees Celsius plus what? 273. So just add 273 to your value given already. So 27 degrees Celsius, that was the temperature scale in degrees Celsius plus what? 273. What becomes the Kelvin temperature? You always make sure your temperature is converted to Kelvin temperature. So 27 plus 273, that's 300 Kelvin. So here becomes 300 what? Kelvin. So then you can see that this is same as 300 Kelvin. So what we do next is just to impute everything into the formula and get the answer. So what becomes number of moles? Number of moles is PV over RT. What's our P now? 0.9211 times. What's the V now? Is it 250 or 0.25? 0.25 dividing. What's the R now? Are we to use this or this? It's only this I explained for, so we have to use it. 0.0821 times. What's the temperature? 300. 300. At the end of solving this question, I'm going to give you one practice question. So you solve and provide the answer in the comment section, whereby number of moles will now be equal to, let's hit all of these on calculator. So 0.9211 times 0.25 dividing 0.0821 times 300. That is I'm having 9.335. Yeah, I'm having 9.35 times 10 power of what now? Minus 3. Okay, minus 3 moles. So bringing this thing, so changing this value to, this is a standard form value. So let's change it to decimal. It can be written as 0.00935 moles. Hope you understand what I just explained. It is extremely very easy. Since you're having a raised power of minus 3, it's going to be 0.00. Make sure you have your 3 zeros, okay? And put this 935. We just shift the point. You understand what just happened? It's very easy. If the options in the question require you to stop here, stop there. If it guys like the option given was in decimal, look for the answer in the option. It's extremely very easy. So then make sure you solve this and provide the answer in the comment section, whereby here will be 200 and here will be, okay, let's leave that like that. And here will be, let's say 560. Yeah, and here will not be this, but at room temperature. Now you can see that they did not give any number. They said at room temperature. What is room temperature? Room temperature has a value. Note it. Room temperature is always 25 degrees Celsius. Do you understand? Room temperature is 25 degrees Celsius. So use that value to solve and provide the answer in the comment section. So we'll progress to the next practice question. Okay guys, let's move over to the next practice question, and it says for question number 7, let's work towards the before we go over to question 8. And 7 says calculate the number of moles. Why would they still asking us to get number of moles? We already know that we have to use the formula N is equal to, depending on how the question is, of moles present in 5.6 dm cube. Wow, this is volume. And in the formulas I have here volume, there's volume here, there's volume here. So which of them am I to use? I don't know yet. Let's finish. Of SO2 at STP. Now note, whenever you hear at STP in a particular practice question, your mind should go over to this formula. Are you following me? It's very, very easy. Whenever you hear it's volume at STP, okay, at STP, standard temperature and pressure, okay, you must make sure that you use this formula written now, which is volume at STP over 22.4 dm cube. Are you following me? What becomes number of moles? What's the volume? The volume given to us was 5.6 dm cube dividing 22.4 dm cube. Are you following me? So 5.6 divided by 20.4, 5.6 divided by 22.4, that's 0.25 moles. Are you following me? It is extremely very easy. Now look at what I just said. Now I want to elaborate more on this formula because it's important for me to say it so you don't need question on it and you don't be able to solve it. Now this must be noted. Whenever, for instance, this volume given to us was not in dm cube, was not in cm cube, for instance, let's say it was not in cm cube, what will you do? Simple like ABCD. Listen carefully. Make sure that this number you are dividing it with will not be in dm cube as well, will be in the same unit as the volume given to you. Do you understand? So if, for instance, okay, let's not call it 5.6, let's just call it another number, like let's say 59 cm cube. I'm just making an example, 59 cm cube, for instance. So now we're still going to use the same formula, but the unit will change. So here will not be cm cube, here will not be what? Cm cube, but not 20.4, but rather 22,400 what? Cm cube. Do you understand what I'm saying? It's very easy. So in summary, if the volume given the question was expressed in cm cube, that stuff, that number you are dividing with will not be 22,400. But if it's in dm cube, it's just 22.4 as seen in the practice example. So make sure you solve this one now. This is your own practice question. Solve and provide the answer in the comment section. It's extremely very easy. I'll just explain what to do. So on question number 8, it says calculate the number of moles. Wow, they are still asking us to get in. Wow, very easy. Calculate number of moles present in. I just say number and I saw atoms at the end. You know that it is that formula you have to use, which is a number of atoms. Number of atoms divided by Avogadro's constant 6.02 times 7/23. So number of atoms given already is 2.06 times 10⁻23 atoms divided by Avogadro's constant 6.02 times 10⁻23 as well. So what becomes number of moles? Do you understand what I just explained? It's actually very easy. So we're having 2.06 times 10⁻23 divided by 6.02 divided by 6.02 times 10⁻23 as well. What are we having? Wow, we are having 0.3422. I had 0.3422 moles. This is the answer to the question. It is extremely very easy. Do you understand? So you can see that we've solved questions that cut across all the formulas. So it is very, very easy. Make sure you give this video a like and also share this video with your friends to help you all improve greatly in chemistry, specifically the topic stoichiometry. You can see that solving questions under this aspect is not the way you're actually thinking it is. It is actually very easy. Do you understand? So that is for that. Let us progress to solve more questions under this aspect. So the next set of questions I'll be solving will cut across me using two formulas together. If you observe, the questions will be solving cut across just one each of the formulas, but now we'll apply two. The maximum number of formulas you can apply to solve a question on stoichiometry is 2 together. You now make something subject. You see the way the question will come. It is extremely very easy. So let us move on to that aspect. Okay guys, let's get into the next practice question, which is the concentration of a solution. Wow, the concentration of a solution. When I see concentration, I'll put that in my mind. Okay, containing 2.65 grams. Wow, 2.65 grams is what? 2.65 grams is mass. I'll put that in my mind as well. Of 2.65 grams of Na2CO3 present in 50 cm cube. Now, what is 50 cm cube again? 50 cm cube, what's that? That is volume. I'll put that in my mind as well. 50 cm cube of solution is, that means they are asking us the concentration of a solution containing 2.65 grams of that compound present in this of a solution is the concentration. What is it? What's the concentration? That's what they're asking us. Wow. So they're asking us to calculate for concentration, which is the unknown. They gave me mass. They gave me volume. They gave us the compound so we can get molar mass. Listen carefully. It is extremely easy. Remember that in this aspect, we are using two formulas together. We relate two formulas. The parameters given to us, you will not try to look for the formula that those parameters are in, so we can actually bring them together and solve. Simple like ABCD. So first of all, molar mass of this compound, how can we calculate it? Because we need it. Definitely, we need. That's why they gave it to us. We need it. So what do? We have to calculate the molar mass together. So molar mass will now be equal to, what's the atomic mass of sodium? Something you should know. Atomic mass of sodium is 23, and we have 2 sodium, so it's 23 times 2, plus carbon atomic mass 12, plus oxygen atomic mass 16, and we have 3 of these. 16 times 3 is equal to, this 106. The compound's molar mass is 106 grams per mole. So we've gotten that already. So let's analyze, everybody. There is mass, there is molar mass now, there is volume, there is concentration. Wow. Which formula has mass and molar mass? This formula. Which formula has concentration and volume in it? Only this formula. So which of the formulas are you relating together? The first and the second. Remember, number of moles is mass divided by molar mass. I believe you understand what I'm saying. And same number of moles again, it is concentration times volume. Now you have to be careful which unit to which the volume was expressed, cm cube. So if volume is in cm cube, what are we dividing by? I've explained initially, we are to divide by 1000. Do you understand? If it was in dm cube, we'll divide by 1. So number of moles is equal to this and this. Same number of moles is equal to this and this. That means both of them is equal to each other. Do you understand what I just explained? Number of moles is this. Number of moles is this. So both of them can be equated together. Do you get what I'm saying? It is extremely very easy. So what do we do next? We equate them together by saying that mass divided by molar mass, which is one formula for number of moles, is equal to that formula which is concentration. Concentration can be written as conc in this short form times volume, and what is the unit of our volume, cm cube, divided by 1000. Understand? So what are we to look for? What are we to make subject? Concentration. Do you understand? Making concentration subject formula, what are we having? Concentration will now be equal to, when we're making something subject, there and this 2 times first, so it's going to be mass times 1000 divided by molar mass times volume. Yes, molar mass times volume. Do you understand? It is extremely very easy. We're going to solve more practice questions to be able to grab this aspect. They are all very easy. So guys, moving further, let us solve for the concentration together. What's the mass? The mass is 2.65 grams. Okay, times what? Okay, times 1000 divided by, what is the molar mass? We've got into 106 times what is the volume? 50. Do you understand? So let's equate it together and put everything into a calculator. So we're having 2.65 times 1000 divided by 100. Okay, 106, not 100. 106, okay, times 50. That is 0.5. Wow, we are having 0.5. And what's the unit for concentration again? Moles per dm cube. So you can see that. So with your unit, you can say all the units are expressed in mole per dm cube. That will tell you that it is concentration they are asking you to get for. So then which one has 0.5? Option A. So the answer to this question goes to option A. It is extremely very easy. So get ready for your own practice question. I'm going to give you your story, solve, and provide the answer in the comment section. It's extremely very easy. Okay, so if you like my video lesson, make sure you hit on the subscribe button. Don't just watch the video and pass. Make sure you subscribe, okay, and share this video with your friends and tell your friends to subscribe so you don't miss out when I upload a new video lesson. Okay guys, here is your own practice question, so you solve and provide the answer in the comment section. Okay, it's extremely very easy. You know that you have to relate 2 formulas. So look at the parameters given to you and know the formula to relate. So you can see that they are asking you to get mass. They gave you volume, they gave you concentration. I believe you know what to do. Simple like ABCD. They gave you the compound so you can calculate molar mass. So I believe you know the formula to apply. I don't say much, okay? So let us progress to the next practice question. Okay guys, let's get into the next practice question, and it says, what is the mass? They are asking me to get mass. It is very easy. Of 2.6 dm cube. Me seeing this, I already know that this is volume. So I'll put that down, volume as well. Volume is what, I don't know if it's volume at STPO, but I just saw volume. I'm going to put it here as 2.6 dm cube, as stated at the question, of which gas? SO2. Me seeing SO2 gas, that means I'm to calculate molar mass. Just put that in your mind, because definitely I'm to calculate molar mass since they've asked me to get mass. because you know that both of them goes together. So if they ask you to get mass and you saw a compound, because you know I told you that it's not all the case you look for molar mass, but in this case definitely they said get mass. How will you solve mass without not knowing molar mass? Do you understand what I'm saying? So then we need molar mass here. We have to calculate molar mass, but we saw the word STP. Wow, I told you that whenever you hear volume a gas at STP, you know that this formula must be used. And now they ask him to get mass, this formula must be used. So it's between this and this. Remember, number of moles is mass divided by molar mass, and same number of moles is volume at STP, okay, divided by what? 22.4 dm cube, right? Yes. So then number of moles is this, number of moles is this. So definitely both of them is equal to each other. Do you understand? So what are we having? It's going to be mass dividing molar mass, okay, is equal to volume at STP dividing 22.4 dm cube. Do you understand? So we cross multiply, making mass subject of formula. What are we having? Okay, what will happen here? I'm going to stop here so you solve this question till the end and provide the answer in the comment section. So you work. It's very easy. Making mass subject, you already know what we times. This time this is divided by this. Impute it carefully. Solve for the molar mass of this compound very well. The compound is SO2. Sulfur atomic mass is 32. Oxygen atomic mass is 16. Do you understand? This is extremely very easy. So make sure you work and provide the answer to this question in the comment section. And the way you do it, make sure you say question 11, the answer is this, so that we don't confuse, you know, so you don't confuse the answers in the comment section. So guys, if you are preparing to write the Jamb exam, post-UTME examination, and you are having difficulty solving calculations in chemistry questions, here is the chemistry masterpiece written by me that will help you improve greatly in chemistry calculations. So make sure you get a copy for yourself because it will help you improve. Okay, all of these calculations done in this video lesson are all extracted from this textbook written by me. So to get your own chemistry masterpiece, do well to direct message me via my number on the screen. Okay guys, moving further, let's get into the next practice question, and it says upon heating 1.25 grams of a solid. Wow, I saw that is mass. I'll put that in my mind. Let's progress. Of a solid, 280 cm cube of a gas measured at STP. Wow, I saw this word STP. That means this formula must be used. Are you getting me? When you see that this formula must be used, it's very easy. We are evolved, okay? 280 cm cube of a gas at STP were what? Evolved. And a residue of this, wow, this is another mass, 0.7 grams was left. What's the question actually trying to explain? And also calculate the question now, calculate the molar mass of the gas. Let's bring out the formula first before I explain the question. You know that this is mass. They asked us to get molar mass, so this must be used. We saw STP, that must be used. So definitely we already know that there is a formula that says mass over molar mass for number of moles. And there's another formula that says number of moles is equal to volume at STP by 20.4. So definitely it should be equal to what? Volume at STP over what? 22.4 dm cube. Do you understand what I'm saying? It is extremely easy. So we are looking for molar mass. Molar mass will now be equal to mass times 22.4 dm cube divided by volume. Okay, now first of all, let's be careful. The volume given to us was not in cm cube, so then this will be changed to 22,400 cm cube. Do you understand? It is easy. I've explained this initially. We can as well just change this to dm cube. You know, to convert cm cube, to convert from cm cube to dm cube, you divide by 1000. But the other way around, you times by 1000. Do you understand? It is extremely easy. So what do we do next? Now, molar mass will not be equal to what? You mass. We have two masses. We have what? Two masses. What do we do? I can't just say, okay, I'll use one. No, you have to be very careful. You have to analyze the question. You have to understand the question. Initially, upon heating, before we heated that particular gas, before the reaction started, the initial mass of that compound was this 1.25 gram. Wow. of that solid or that compound. So the reaction has started, and the reaction started. 280 cm of that gas were measured at STP were involved. So at the end of reaction, 280 cm of that particular gas left. That's volume. We're not talking about volume now. I'm interested in the mass. So, and a residue of this, you have to know what residue means. Residue in chemistry actually means what is left, the mass of something left. So at the end of reacting with this mass, at the end of reacting, this was what was left. So you have to now calculate the mass that was involved in the reaction, the mass they actually used during the reaction, because this was the mass given to us initially, and at the end of the reaction, this was the mass left. Which of them will now use? You have to now subtract 1.25 minus 0.7. Yes, to know the mass of that particular substance that actually went to reaction. Do you understand what I'm saying? It's simple. So then 1.25 gram minus 0.7 grams, that's 0.55 grams. So mass now that actually reacted is 0.55 grams. So then that's what we have to use here. 0.55 times 22,400 dividing volume, which is 280. What becomes the molar mass? Molar mass will now be equal to 0.55 times 22,400 dividing 280. That's 44. Wow. 44 grams per mole. Do you understand? It's actually very easy. I'm going to give you your own to provide the answer in the comment section, whereby here will be like 1.75 and here will be like, let's say 0.9. Okay, we'll leave the rest like that. Solve and provide the answer in the comment section. It is extremely very easy. Okay guys, let's get into the next practice question. Okay, meanwhile, in this set of questions, it is on what we call stoichiometry of reactions. Here, you'll be given reaction. Do you understand? So you have to understand how questions like this can be solved. I'm going to explain for you. So now the question says, calculate the number of moles. Wow, they are still asking me to get number of moles, which is N. We'll put that in our mind, okay? Of oxygen. You are calculating number of moles of oxygen. Where is oxygen in this reaction? This is oxygen in the reaction. You still underline it or circle it because it's going to help us. Calculate the number of moles of oxygen provided from the decomposition of. Provided from the decomposition of. Decomposition means breakdown of 5 moles of KClO3. This is KClO3. Okay, 5 moles of what? KClO3. See, whenever I see questions like this, it must be noted here that on stoichiometry of reactions, you must know 2 things. What are they? What you are looking for, what you are asked to get, you must outline 2 things out. What you are asked to get and what you are given. What are we asked to get, or what are we asked to calculate for? It's not number of moles of oxygen. That's what we are asked to get. What were we given? 5 moles of KClO3. Do you understand? When you see that, and we are relating just 2 things here. It's still like the previous, but that one is formula. Here we are not relating formulas. We are relating 2 things. 2 things. Substance, 2 substance. Do you understand? Like a substance can be either an element or a compound. Do you understand? That's what I'm saying. We can relate 2 sets of substance or 2 things, which is what you are looking for and what you were given. What are we looking for? Oxygen. What were we given? 5 moles of KClO3. When you see that, you can say I've outlined them down. So then I'll bring them down. So it's going to be KClO3. The way it is in the reaction, you bring it out. That's 2 KClO3 to give me what? 3O2. Do you understand what I just explained? It is extremely very easy. Like you bring them down, which I've done. So then, you now then do this. The number standing in front of them, you now then write underneath them 2 moles. You can see how I got 2 moles now. The number standing, I'll bring it down. So give me 3 moles. Do you understand what I just did? This is how it should be done for any type of question. It is easy. You can do it. So after doing that, what do we do next? The value they give. Now, what are we looking for? We are looking for the number of moles of oxygen, X moles. Here, we are not really using the formula. Like, we are not really using the formula in this aspect. Don't worry, just listen. So what are we looking for? It's not number of moles of oxygen. Yes. So it is X. That's what we are looking for. What were we giving for this guy? 5 moles. of KClO3. Do you understand? It is simple. If it was 10, put it as 10. So in summary, once you are done outlining what they give to you in the question, like what you're interested in, what you are to look for, and what you are giving, after you are done identifying that, you bring them down the way it was written. You can see I have no business with KCl again. That is out already. And then bring the number of moles standing in front of them. You write it first before you do anything. Write it first, and then now go to what you're looking for, and underneath it, because it's oxygen, and make it as X. So give me 5 moles as given the question. So cross multiply. Let us make X moles up there, because that's what they're asking to get. X moles will now be equal to 5 moles times 3 divided by 2. So what become X moles? X will now be equal to 5 times 3. That's 15 divided by 2. That's 7.5. So X will now be equal to 7.5 what? Moles. Of which guy? Oxygen gas. Do you understand? Like you write your ox, you can spell it or just write it O2. Don't write it in front of it, or just O2. It is oxygen. We've utilized 3 already. Do you understand what I just said? It is extremely very easy. You know, this part of chemistry is very, very important. Okay, I already have video lessons that explains on every single thing you have to know on stoichiometry. In this particular video, we are interested in solving practice questions, which I've been solving. You can see we've solved so many, and I've given you your own practice questions. Do you understand? They are all very easy. So if you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share with your friends. Okay guys, let's get into the next practice question, and it says calculate the number of moles of HCl. Wow, we already know the rudiments under this aspect, which is stoichiometry of reactions. Remember I said that we are interested with 2 things: what they are asking you to get and what they give to you. So they are asking to get the number of moles of HCl. Wow, where's HCl in the reaction? Here is the reaction. HCl is here. And also, whenever you are solving questions under this aspect, make sure your reaction is balanced, because in exam conditions they might just give you the reaction unbalanced, and you might not just, you know, try to look at it to know if it's balanced. So make sure you always look at it if it's balanced, because they can actually give you the reaction unbalanced and solve with that unbalanced reaction, and there will be an option to that particular aspect which is for the unbalanced reaction, and there will still be an answer. There will be an option in the question, do you understand, that has that particular answer for that unbalanced reaction, and they will still solve for they will still solve when the reaction is balanced. Do you understand? And most times you might not even look at the reaction if it's balanced, and then you will then just solve like that and get an answer which is wrong. So you have to make sure you check if the reaction is balanced, and to do that is simple. Do you understand? To balance chemical reactions is actually very easy. Do you understand? So the reaction is balanced. Okay, this is balanced as well. So moving further, we are looking for this. We are looking for the number of moles of HCl. Okay, that will be required to react to 5 grams of sodium hydroxide. Wow. Okay, so we are relating both of them. Do you understand? This sodium hydroxide, we are relating both of them. Bring them down, as I've said. HCl will now give me what now? NaOH. And now you can see that there is no number standing in front of them. We'll make them 1. There is an invisible one though. So it's going to be 1 mole of HCl to give me what? 1 moles of what now? NaOH, right? Yeah. So what do we do next? It's going to be this. Now, we are looking for the number of moles of what? Sorry, we are looking for the number of moles of HCl. So it's going to be X moles. This is the unknown. It will not be equal to. Can I write 5 grams here? Don't do that. Don't do that. Do you understand me? You have to make sure that they are in the same units. So then, what do we do? That is why the knowledge of what we've learned initially is very important. You have to make sure that you convert 5 grams to moles. How do you convert moles? How do you convert grams to moles? Simple now. And they gave you the compound to get molar mass. Use your first formula, which is number of moles is equal to mass divided by molar mass. Because we are converting this 5 grams to mole, because that's what should be here, not that 5 gram itself. Because if you put that, they will not be in the same unit, then it's wrong. So number of moles now, because what's the mass? The mass is 5 grams divided by the molar mass of NaOH. Now NaOH, you know, sodium here is 23 atomic mass, and oxygen is 16, hydrogen is 1. So it's going to be molar mass will now be equal to for NaOH, watch carefully, it is simple. So it's going to be equal to sodium 23 plus oxygen 16, hydrogen 1. What's that? 23 plus 16 plus 1. 23 plus 16 plus 1, that's 40. So here is 40 grams per mole for the compound. So the molar mass of the compound becomes 40 grams per what? Moles, whereby gram cancel gram. So 5 divided by 40, that is 0. Number of moles, now because 0.125 moles of NaOH, that should be here. So here becomes 0.125 moles of sodium hydroxide. Do you understand? So then we'll cross multiply, making x moles subject of formula. So x moles will now be equal to 1 times 0.125 moles divided by 1 moles. So then what becomes x mole is still the same. 1 times that divided by that is still 0.125 moles of which one now? HCl, because we are looking for HCl. HCl, simple. Do you understand? Questions under this aspect are extremely very easy. You just have to follow the rudiments step by step. Do you understand? So you can actually solve any question under this aspect. So get ready for your own practice question, so you provide the answer in the comment section. Okay guys, here is your own practice question, so you solve and provide the answer in the comment section. It is extremely very easy. You have to be careful. Now they are not asking to get number of moles, they are asking to get mass. I'm going to explain this question for you so you can solve it. They are asking to get mass of what? Iron. So you go back to your equation and look for the equation is balanced. I can't give you an equation that is not balanced. The equation is balanced. You are relating iron. Remember, it's two things you are relating. Iron that would be required to react with what? 250 cm cube of 0.1 mole per cube HCl. So you are relating both of them. So you bring them down. Iron to give me what now? 2 HCl. Do you understand? Remember, it is 1 moles. I think I will stop here. So you finish it. 1 moles to give me what? 2 moles. So what do you do next? Simple like A, B, C, D. Remember, you are looking for the mass of iron, but before you get mass, you have to get your number of moles. So here become x mole. So what should be here as well? What value should be here? Should the number here be any other number, or number of moles, or a value expressing moles? A value expressing moles should be here. And they gave you, it's for HCl, and they gave you parameter that you can convert to moles for HCl. You know you can convert 250 cm cube of 0.1 mole per cube to moles. Yes, you can now. This is volume, this is concentration, this is volume. Use this your formula. But now volume is expressed in cm cube. Okay, you must divide by 1000. Do you understand? We've said all of these things. Make sure you solve this question and provide the answer correctly in the comment section. And then after getting your number of moles for this, and then get your x for iron. After getting your number of moles for iron, number of moles of what? Iron. Will you stop there? No, you won't stop here. You convert it to mass, because they say what is the mass. So then you still use your number of formula again, which is number of moles equals to what now? Mass divided by what? Molar mass. Okay, the atomic mass of iron, because you need it, is 56, which is the molar mass. So then making your mass subject is going to be n times what? Molar mass. So what become your n? What you have to get here after converting this to moles. So then the n you have to get here is times with your molar mass to get the mass of iron. Do you understand? It is simple like ABCD. Okay guys, we've come to the end of this video lesson. If you find my video lesson helpful, make sure you subscribe to my channel and also share these lessons with your friends. Thanks for watching. To have more understanding about chemistry calculations and solving all of this type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the Jamb exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.